Welcome to Test 2 Review. Please make sure you're practicing with your calculator because you can totally check these by a variety of methods like we talked about in class, and I'll review a few of them if we have time because, again, I don't like this to be too long. So for our first equation, when you have a fraction, you have three choices. You can either deal with the fraction, you can go decimal, or you can multiply by the lowest common denominator of the fractions to remove them. I'm just going to deal with it because it's only a half. So I would do the opposite of adding 3, which is subtracting 3. And hold on, the pen's not working. Come on, pen. Okay, hopefully now it works. All right, I would do the opposite of adding 3, subtracting 3, and that would give me 1/2 of an x is equal to 4. And then the opposite of multiplying by a half would be to multiply by the reciprocal, and the reciprocal of 1/2 is 2. So I'm going to multiply everything by 2, and remember that's a property of equality, so when you multiply one side of the equation, you multiply the other side of the equation. So that gives me x equals 8. And I can check that using mental math. I can check that on my calculator. There's so many ways. All right, so now this one, I'm going to use the distributive property. I'm actually going to use it twice. So the first one is fairly simple. That's 3x plus 15. The second one, I do have to be careful because I'm multiplying by a negative number. So that's going to be minus 4x minus 10 equals a negative 2. I like to combine my like terms and then know what I'm dealing with. So I'm going to combine the x's. That gives me a negative x. You could also write a negative 1x. And that's going to give me a plus 5 equaling negative 2. So the opposite of adding is subtracting. So I subtract 5. And that gives me negative x equals negative 7. There's a couple ways you can think of that. If the negative of x is negative 7, the positive of x is positive 7. Or you can multiply or divide by a negative 1 because that is the coefficient. Okay, and again, this can be checked. So you can do mental math and check it, or you can put it in your graphing calculator and check it. Okay, fraction, fraction, fraction. There's a lot of fractions. Whenever there's a lot of fractions, I really always use an LCM. So I'm looking at 2, 4, and 6. I'm going to work with the 6, and I'm just going to count by 6. So 6 works for 2, but not for 4. 12 works for 2, works for 4. So I'm going to multiply everything by 12. That's called the lowest common denominator. That gives me 3x plus 6 equals, and if you're not sure how to multiply by a fraction, you can always use the calculator, but it's basically divide by denominator, multiply by numerator. So 12 divided by 4 is 3. 12 divided by 2 is 6. 12 divided by 6 is 2. 12 divided by 2 is 6. So now I'm just going to combine the like terms by moving the variables to the other side. And I'm actually going to just do both at the same time. So this is something that I do to save myself time. I did the opposite of having 2x, I subtracted 2x, and I did the opposite of adding 6, subtracting 6. And you'll notice that negative 2x minus 6 is the same as negative 2x minus 6, so I added the same thing to both sides. That gives me x equals negative 12. I would totally check this on my calculator if I were you, because anytime something's with fractions, we're always just a little bit vulnerable to making mistakes. Okay, now this one only has one fraction, so I'm just going to deal with it. I'm going to actually try to make it into a fraction equal to another fraction and then use cross products or proportional reasoning. So I'm going to start by subtracting the 7. That gives me 2. Actually, I'm going to distribute to save a little time. That is not an eraser. All right, I'm going to just cross it out. Sorry for being sloppy. 6x minus 2 over 5 is the same as, so I just distributed to save a little time, and then I did the inverse of adding 7, subtracting 7, and that gives me an 8. So I have a fraction on the left side, and it's pretty simple to make a fraction on the right side. I just put the 8/1. So now I can use cross products, which is numerator, denominator, cross products. So that's 6x minus 2 is equal to 40. 6x times 1, 5 times 8. Once I get it here, they're pretty simple to solve. So the opposite of subtracting 2 is adding 2, so that gives me 6x equals 42. And then the opposite of multiplying by 6 is dividing by 6. And that gives me x equals 7. Okay, bunch of ways you can check this stuff on the calculator. I'm going to just write this down because I don't have the paper next to me, and then I'm not going to be able to remember it when I go to type it in my calculator. So I have 2 times the quantity, 3x minus 1 over 5 plus 7 equaling 15. All right, so I'm going to go to my calculator with my answer, and my answer is x equals 7. So I'm going to do the storing method right now. So here's the calculator. Hopefully it'll come up. I'm going to clear out what I have. Okay, and I'm sorry, I'm a little slow on the calculator that it's not in my hand. So 7 store as x. Enter. So now, whenever I type the letter x, it's going to automatically substitute the number 7. So I'm going to type the fraction. Alpha x gives me the fraction bar. 2 parentheses 3x minus 1 close parentheses over a 5 plus 7. And what I'm hoping I get is an answer of 15 because that's what it says. And I did, so I know my answer's right. You can also use the test mode, and that's you take this left side expression and you do second math, which is test. Math test, it's something good to use. And that gives you an equal sign, and then I put equals 15. And if you get a 1, that means true. If you get a 0, that means no. I don't usually do the test method when it's variables equal to just a number because I can easily just look 15 equals 15. Okay? All right, so that's that. Use your calculator to check. So one solution, no solution, and infinite solution has to do with whether or not you have the same thing equal to the same thing or something equal to a contradiction. One solution, as long as it's not 2x plus 1 or 2x plus another number, it's always going to have an answer. So I'm just going to write 3x plus 3. You just have to make sure that you have a different number of variable or a different number of x's. So you can't have 2x on one side and 2x on the other side. That's either going to give you no solution or infinite solution. Okay? So for no solution, I have to have a 2x because you want to have the same amount of variable. And then anything other than a positive 1. Anything other than a positive 1. Because positive 1 will only equal positive 1. Now for infinite solutions, you want the same thing equal to the same thing. Okay, one solution when you graph it, you're going to get intersecting lines. No solution when you graph it, you're going to get parallel lines. And infinite solutions when you graph it, you're going to get one line on top of the other. Yeah, I have to get a better pen. Use your calculator, it'll help. Okay, solving for B. So I know that this is hard, and what I would definitely do is I wouldn't really focus on what the answer looks like because the answer is not checkable. I would focus on, did I do the right thing? And doing the right thing would be, did I combine the like terms? Did I use inverse operations? So they want me to get B alone, which means I want the 1/2 to go away and I want the H to go away because I want the B to be alone. So the opposite of multiplying by 1/2 is to multiply by 2. That's going to give me 2 capital A equals BH. You do have to make sure you keep capitalization. So this is considered case sensitive, like a password is case sensitive. So now all I have next to the B is an H, and that's multiplication. So I divide by H. and that gives me B equals 2A over H. And really the only thing you can do is say to yourself, did I do the opposite? Did I do the opposite? And if you did the opposite, you should be fine. Okay, so now for this one, I do have a -7c and a 2c, so I'm going to combine them. I'm actually going to move the -7c, which is something we might not normally do, but remember the idea is moving away from the b. So I'm going to add 7c to move away from the b, because I'm solving for b, so I'm moving away from the b. And that gives me 2b equals 3a plus 2 plus 7 is 9. And now I'm just going to divide by 2 because remember, I'm trying to get the b alone. And again, these are hard to check because you're not getting a number. You get b is equal to 3a plus 9c over 2. And again, I would just ask myself, did I do the right thing? So the opposite of subtracting 7c is adding 7c, and I did add correctly. And then the opposite of multiplying is dividing. And that's really it. Okay. Writing an equation to solve. You have to bring in a lot of outside information to do this because you have to know certain things. It's not going to be anything obscure or strange. It's just going to be like everyday stuff. So you do have to know how much a dime is worth and how much a nickel is worth. So Jenny has some coins. She has dimes and nickels. Dimes are 10 cents, nickels are 5 cents. And I really hope you know that. She has 5 more dimes than nickels. So that means for dimes, I'm going to use x plus 5. 5 more means add 5. And since a dime is worth 10 cents, I'm going to put 0.10. You could put 0.1, but honestly, I would leave money to look like money. And then nickels is 0.05. Be careful, that zero is really important, otherwise it looks like 50 cents, and a nickel is not 50 cents. So then the x goes here, and it's equal to $1.55. Okay? To solve this, you would just use the distributive property, combine like terms, inverses. So I would get 0.05x plus 0.10x plus 0.1 times 5 is 0.5. I'm going to make it 50 cents. It just looks nicer. And then $1.55. So when you add your like terms together, you get 0.15x. And then subtract the 50 cents, you get $1.05. And then you have to divide $1.05 by 0.15. $1.05 divided by 0.157. If you don't get a whole number, you did something wrong because you can only have a whole number of coins. All right, so x equals 7. So that's 7 for the nickels. And 5 more than 7 is 12, so 12 for the dimes. Okay, not bad. All right, perimeter. Perimeter goes around the outside, round the outside, round the outside. Use a W. Try to use the letter they give you, but if you don't use the letter they give you, you can just cross out the W and make it an X if you accidentally use an X. I do that sometimes, it's just like habit. The length is 5 meters more, so again, that means to have 5 more. And perimeter goes around the outside, so there's 2 widths plus 2 of the lengths, and that's going to equal 46. And you know, there's a lot of things you can do here. Some kids actually cut the perimeter in half and just do 1 width and 1 length equals 23, and that's cool. So I get 2W plus 2W plus 10, which is the same as 4W plus 10, equaling 46. Subtract 10 from both sides, so 4W equals 36. Divide by 4, so W equals 9. I'm just going to draw a new picture. That's 9. 5 more than 9 is 14. And then check it in the calculator. Okay? All right. Consecutive, even. All right, so here, just make sure you read the word even or read the word odd, or if it's not there, obviously it's not. So for even or odd, you would do x, x plus 2, and x plus 4. And that's because, like, think about how do you go from like 2 to 4? You add 2. How do you go from 2 to 6? You add 4. You could always draw a number line. It is helpful. Sum means to add, so I'm going to add those together. So that's 3x plus 6 equaling 132. Subtract 6 from both sides. 3x equals 126. Divide 126 by 3. I feel like it's 42, but I'm just not trusting myself today. 42. So x equals 42. That's nice because it's an even number. So then it's 42. 2 more is 44. 2 more is 46. All right, I'm in the dark, but I'll keep going. Oh, which of the following will have an irrational answer? Okay, 1/2 is rational. -5 is rational. It's an integer. So that's going to be rational because the set of rational numbers is closed except for dividing by 0. Okay, this is rational. This is rational. So again, the answer is going to be rational. Here we go. 2/3 is rational, but the square root of 8 is not. So that's going to be irrational. And that's because rational plus irrational is always irrational. Happy studying. Feel free to email if you have any questions. I would definitely look at the extra practice Regents questions at the back of the packet. Those are always really useful. If you don't know something, you can always Google it. And please use your calculator to check on your test. It really, really helps. Have a great night.